All right, good morning, good evening. Welcome to lab number 3, DFIR 8, process investigation. Our lab objective is to gain hands-on experience with forensic investigation methods learned during the lesson. Lab mission, mimic bind shell behavior and investigate it using live analysis of the process directory. That's slash PROC. All right, you will need your Ubuntu machines for this version 20.04. First thing I want to do, lab task, bind shell investigation. We want to basically mimic our bind shell, and we're going to start doing that by using the netcat. We're going to copy netcat from the bin directory over to temp slash bind shell, right? We're just trying to copy this. So let's go ahead and do that. Let's do cp slash bin slash netcat. Move this over to the temp bind shell directory. Okay, let's go ahead and verify that. All right, our bind shell is here. Fantastic. Clear that out. All right. So now we're actually going to start the bind shell, and we're going to have it set up a listening port, and we're going to pipe that into dev null. So let's go ahead and get that started. So I'm going to navigate to temp, and let's go ahead and start the bind shell process. I'm going to set it on a listening port of 1339. I'm going to pipe this to slash dev slash null. And I'll have this running in the background. That's what this and symbol does. So let's make sure that looks good. If you get a temporary failure in name resolution, you might need to edit your etcresolve.conf. So let's go ahead and take a look at what mine looks like. I'm going to change mine to 8.8.8.8. You know, in fact, even better, I'm going to say no. I'm going to do that again, but this time I'm just going to comment out this one in case I need to revert, follow best practice here. Okay, that looks good. We're using Google as the name server. I'm going to go ahead and save this. Yes, okay. Now I'm going to do this again. All right, that looks good. All right, good. We are now listening on 1339. Fantastic. Now they want us to remove the temp bind shell. So I'm gonna make a new tab here, and I'm gonna do rm slash temp slash bind shell. All right. I do ls dash h. We scroll up here. The bind shell folder is now gone. All right. Next, we want to see what is open, what processes are open. So we're going to do that with the lsof command, which we have used in the past. So let's go ahead and verify that our bind shell process is in fact running here. So I'm going to do lsof -i -n -p -l. We can see, in fact, yeah, the bind shell process is running and it is listening on our port 1339. So we are happy there. Make a note of your process ID, right? Mine is 2018. I'm going to jot that down here. PID 2018. I'm going to say bind shell. Might need that later. Okay, next, I want to see if I can find that process in the proc directory with that process ID of 2018 that I just listed here. So let's see, because each process is mapped directly according to its PID. So here's what I'm going to do. I'm going to go to cd slash proc slash my number 2018. Okay, then let's just list out the content. So we got a lot of stuff in here, some attributes, some command line, input output, GID map, NUMA maps, user ID, syscall. So a lot of stuff in this actual process here. So what we want to do is we want to recover the command line parameters used to execute the binary. So I'm going to use the cat command line on this one right here. So let's do this. We're going to do cat command line. And you can see right here, this takes me to my bind shell, and there's my port, and there's my location. All right, so now I want to look for evidence that the process communicates over the network. There are two indicators that may prove network communication: network libraries and socket connections. So I'm going to run cat maps to show the libraries. Then I'm going to run ls-la/fd to determine if the sockets are used. So let's go ahead and let's do the, let's make a new tab here, and let's do cat maps. And you can see right here, we have a lot of libraries listed here, right? And we get different attributes, tells us lots of different things here. We see that we have some stuff that has been deleted here. All right. Next, they want us to look for sockets, see if any sockets have been changed here. So let's go ahead and do that. I'm going to type ls-la fd slash, and we're seeing some content here, right? We've got our pointers, we got dev null being updated here, and we have our current listening port right here. So we do have active connections, active network socket connections. So that indicates that, so far, so good. And before we move on, I forgot to tell you that there is this right here, this lib resolve. These actively tell us that we have network connectivity. That is the point of this library, libresolve. So again, one more indicator that shows we have network connectivity here. All right. And the contents of the FD folder can help determine if the sockets were used as file descriptors. Right. Our next task is to obtain information about who or what started the process, and we're going to use the strings in virn command. So first, let's see if it works. If it doesn't work, I might need to install it. So let's go ahead and just type in strings in virn. All right, that did work. I did not need to install it. But again, this could tell us, hey, who is doing some modifications on the system here. We're not seeing too much information in this case, but this can still be used to reveal who ran the executable and how the user was connected, right? What port were they on? What port did they connect to? This will be able to tell us some of that information here. All right. Next thing is we want to obtain the deleted binaries hash and compare it with the original binaries hash. So let's go ahead and do that. We're going to use the cp command and we're going to copy. We're going to copy exe slash temp slash recovered. All right, so let's go ahead and do that first. So I'm going to do cp exe slash temp slash recovered. Okay. And I'm going to get a hash of that file using md5 sum slash temp slash recovered. All right. Take a note of that. Again, this is what we erased earlier. So we got our hash here, right? Next one, we're going to take the same hash of the file that we had copied in the beginning, the netcat file. So let's go ahead and do that. So I'm going to do md5 sum slash bin slash netcat. And as you can see, we're able to verify that what we erased was what we copied before, the netcat file. And the MD5 sum can prove the integrity of the file. And that is the end of lab number 3.